Hello, everyone. Well, today we will try and take a look at a question which comes in interview questions about Node.js and JS in general. So the question is basically one that relates to a method of calculating pi. And if I had to summarize it, I would use a little picture here to just display the principle. In short, imagine this being a quarter of a circle and this being a rectangle, where not a rectangle, it should be actually a square. So it's kind of rectangulish here. The drawing is not top notch, and the circle is kind of squishy, looks more like Earth because Earth is far flatter on the North Pole than it is on the equator. But imagine this being a quarter of a circle and this being a square. And the idea is if you were to randomly throw points on this surface here, on this entire surface, you would find that the likelihood for a point to fall inside of the circle, and let's just assume for the sake of simplicity that the circle is a unit circle, so the radius here is 1. Well, that likelihood will be pi divided by 4, while the points that are red that fall outside of the circle, contrary to the green ones, um, they take the remaining likelihood, which is 1 minus pi divided by 4. So, knowing this principle, the interviewer asks you the question, well, could you write me a method which calculates or gives an approximation to the number pi? It goes without being said that obviously the number pi is not a number you can calculate very precisely, and that precision is, well, it's another task of numeric method utilization. So to summarize, this relates to an approximation called the Monte Carlo approximation of pi. And so basically what we need to do now is think about a way to use that principle in calculating the number pi. Note that there are a number of variations of how this question will be asked to you. And so I'm giving you the most drastic variation, which is just understanding the principle, deal with it, and give me some approximation of the number. There are far easier variations, which are uh, what shows you a number of steps in how you do it. So going back to the schema or to the picture, what you find is, first of all, you take a, a number of points and you throw them randomly. So the keyword there is random, and the other implicit keyword there is a lot of points. So that's one part we might want to try at first, and we will do so by very simply just generating an array of points. Let's call it array of points. And that array of points, at first it will be void or empty, but then we will create a little loop here and say, let's go for e starting from 0 to e inferior to 1. It needs to be some substantially great number. The greater the number, the greater the likelihood that you might find some relatively good approximation. And what you would do is, in simple terms, just um, create random coordinates and throw them inside of the array. Well, what that means is, let's call a variable x, and in x we will target a random method, and the random method returns a pseudo-random number between 0 and 1. This actually works for us in our case scenario because we've assumed that the radius of our circle, this thing right here, is actually 1. If the question says it should be something different, then you should adjust by using a parameter. How you would do that? Well, in simple terms, you will take whatever results you got here and multiply it by some radius variable. And then you get to choose the radius variable if you want to be generic here. Well, you'd need to write it somewhere in here to not repeat greater than its own number of times, and you would just call it radius, and in our case it would be 1. It could be something different, might change. Okay, so knowing this, what we'll do is just multiply here, and we want to get also the y coordinate, and it will emanate from a same formula. Okay, and basically this lands us two coordinates. Now what we can do is just push it inside of our random array of points, and we do so by doing actually an array of points, push, and we can push them in a number of ways. We will just be simple here and push them as an array themselves, so x and y. Now the choice of the data structure belongs to you. You might very well imagine doing this in a different manner. For example, you can do array of points, push, and this would be actually x taking value x and y taking value y. All right, or some other definition where you should call it, I don't know. You can call it x coordinate and the other one y coordinate. But anyways, that data structure belongs to you, and you can deal with it, and you have to deal with it later on. So we don't need this, and we will reactivate this little line. So in the end, what have we done up till now? And just simply iterated over and over about 10,000 times in one time to produce random coordinates which will play as points. For the sake of comment, this xy thing here, it does represent one point thrown randomly on the square with the circle, with the quarter circle inside of it. Now, this is really being very explicit. All right. One first step as a developer is that you want to obviously know you didn't make some very dumb mistakes, and at this stage you just want to console log whatever you got there. It's going to be a doozy, and probably this is a console log you want to try out inside of the loop just to have a number of lines doing the thing. So let's go ahead and print out xy. And if we try this, it doesn't show anything. Why it doesn't? Well, because I am dumb enough not to call the function. The lovely life of a programmer. So basically here, we'll just call upon this method, and we should be good to go. Oh god, this is both intimidating, fantastic, and memory wasting. But you can notice, yeah, we've done the deed. You have coordinates between 0 and 1. Fine. Now, let's go back. Yeah, we know this spot works. And let us remember what we wanted to do. We was just wanted to create an array with this kind of input because we want to use it to calculate pi. Now, how would we use it to calculate pi? So remember, the idea, again, is If you were to throw an infinity of points on this square with a quarter of a circle inside of it, you would have a pi over 4 likelihood of points falling inside here and the rest falling outside. So the concept is, randomly speaking, or pseudo randomly speaking, because this random baby here is a pseudo random generator, we should have a distribution, an actual distribution of points which verifies that likelihood. So what that means is, should I take the number of points randomly generated inside of the quarter of a circle, they should be pi divided by 4% of the total points generated. Now, understanding it like this, you can see where we're going with it, and it should be fairly simple. In fact, all we need to do now is a little test. And by the way, is a little test, but then I'll go to a little bit of optimization after which. And the test is, if the point randomly generated falls inside the circle, add it to some counter. Else, don't. But keep the number of the total points. Why do we want to keep the total number of points? Because we were going to generate some form of ratio, to calculate some form of ratio. What does it mathematically mean that a circle belongs to a radius equal to 1 circle? Well, this is where you need to know some math, but probably the interviewer will help you with that if you are not very keen on mathematical concepts, because that's probably not your job at this point. This is, I'll just first write this as a comment, and as a comment it should be, sorry, I have to push this thing here because coding style is important. The test is, if inside the quarter circle a point of coordinates x and y will verify x to the power of 2 plus y to the power of 2 should be inferior to or equal to the number 1. Magic, 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 magic. So there it is. Now, this in programmatic terms with JavaScript, it gives you something of this type. Let's use the bow method. Take x and raise it to the power of 2. Add to it math bow y raised to the power of 2. And verify if it's under 1. If so, well, there now you need some counter, and the counter you cannot put inside of the for loop because it will forget itself. You can imagine. So it cannot be a constant, it should be a let. And let's call it something meaningful. It should be number of points inside. Starting from 0, give some space. Linting is very important. And now, what do we have here? Well, just increment this baby. If not, we do not care. By the way, we've said something in this thinking comment, which was, but keep the number of total points. Well, that number we actually know. We know it's 10,000 plus 1. Okay. And let's just round this one up so we avoid falling in any situation. Well, no, not really. Sorry. Because this is a strict comparison. So we do not touch the 10,000, and actually 0 is fine because it lets us calculate 0 until 9999. Look at me being a German. So there it is. Now, actually, I'm starting to wonder at this point, do I really need this push? Well, not really. Why not? Well, because unless I want the information of what actual numbers fell into the circle, which is not the case, to be honest, the fact remains that I just want to know if a point which was randomly generated fell or not. And this is answered by this conditional test. So this baby here will, in my opinion, disappear. And after all, we will make it disappear. If we need it back, we will get it back. Life is not hard, is it? Cool. So now, um, let's go for the test. So what we return is the number of points inside divided by the total number of points, which is 10,000. But let's just remember, we've spoke. I didn't mention it in written anywhere here. I hope you have a great memory of sounds because I've just mentioned it passing. The likelihood is actually to be to have a green point. It is pi divided by 4. It's not pi. So that's forces us to have just a small modification here of actually multiplying by 4. And yes, sure, you can simplify this whole formula, but let's be very honest, I don't like having magical numbers in my functions, nor do you, or nor should you in an industrial context. So whenever I see a magical number, there is automatically a principle of keeping it into a constant, and a constant is a constant, and that means let's call it population. All right. In this instance, I can push it to be 10,000. The advantage of that is I'll be using a constants everywhere. And the other advantage is, should I one day think of modifying slightly my function by, for example, making it an input, meaning I don't want to enforce 10,000 particularly, I want to allow my user to make larger or smaller the population depending on their needs. I can use this as an input, so that change will be very quick. So there it is. Well, we've done a fine job. Let's go for a run test now. Ooh la la! It returns nothing, as it should, because approximation pi returns actually my number. It doesn't return. It doesn't console log it. So no fear. We'll use a constant, and let's call it approx by. I don't like these names. Approximated by is more of a significant name of a variable. Please pick significant names to your variables. It does save lives. And with every bad naming you choose to a variable, a kitten dies somewhere in the universe. So there you have that on your conscience. And just let's console log it with something neat here. Say approximated pi is approximated pi. And now for the run test. Ooh la la! Doesn't look very neat. Bloop, 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 bloop. Well, you see it's not fantastic, but it's a firm answer. And leave it to another video, because this one is getting already very or far too long, to maybe try and make this a better answer. But if you show this to your interviewer, they'll think, well, this guy is not so bad, is he or she? Well, thanks for watching. Take care of yourself and see you next time.